Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Norzarul Shafira Idayu binti Muhammad Saufi with metric number 1170884. My supervisor is Dr. Sheikh Shahrul Nizam Sheikh Zahari. So Alhamdulillah, today I will present about my paper review on title Synthesis of Hematite Nanoparticle by Wet Synthesis Method. So in my presentation, I will explain about the four thing, which is the introduction. Second is the very essential part, which is the methodology. Next is the instrument, and last but not least is the conclusion. So let's move to the introduction. So the background of the study. Hematite is the types of iron oxide that we can found abundantly in the nature. It is the most suitable phase of iron oxide compared to other phase. For example, magnemite. So here I provide a real picture of nature hematite that we can find it in the soil. So they can be varied in color. They can be black to grey or red to reddish. So the hematite has a great potential in many fields, especially in the magnetic field, such as the photocatalyst and the medical application, as it exhibit a magnetic properties. So the hematite consists of 70% of iron and 30% of oxygen. And well crystallized hematite tend to form flat trigonal crystal system. This crystal system can be understood while looking at the lattice crystal system, where the structures consist of a dense arrangement of iron ferrite in octahedral coordination and the oxygen in hexagonal closed packing. So the hematite nanoparticles show a great potential to many fields compared to the bulk hematite. If you can see the same images here, the comparison of bulk hematite and the nanoparticle hematite. Logically, the nanoparticle hematite can show a great potential compared to the bulk one. So the further research on synthesizing hematite nanoparticle is very essential to maximize its potential in each field. So the aim of this paper review to study the synthesizing technique of nanoparticle by the wet synthesis method, which is the sol-gel, co-precipitation and hydrothermal method, and we want to elucidate the effect of different parameter to the hematite properties. So let's move to the methodology. Okay, basically the methodology of synthesizing nanoparticle, there are two, which is the physical and chemical methodology. So here, in my paper review, I focus on wet synthesis method, which is the chemical method. There are three wet synthesis method, which is sol-gel, co-precipitation method and hydrothermal method. So each of the method I will explain about the principle, and I will summarize about what I have found in my reading. So we start with sol-gel method. So basically the sol-gel method is the mixture of metal alkoxide and the solvent and the suitable solvent in a water. So the solution will be matured to form a sol. Then the sol will be heat at a desired temperature to form a gel. Then the gel will be calcined. And last, we will get a hematite nanoparticle. So this is the paper review that I have summarized in this table. So looking at the paper by Shakil Akbar, they want to observe the average of particle size and the magnetization of hematite. So the controlling parameter is they manipulate the aniline temperature and the precursor concentration, which is the citric acid, and what they have found is the average of particle size decrease with increasing the aniline temperature and the citric acid concentration, and the magnetization increase with increasing the reaction temperature. So the reason behind this phenomena is the citrate ion act as a ligand, support the growth of the smaller particle. Okay, so second is the Kiraja et al. They want to observe the effect of chloride ion to the morphology of the hematite and the reaction temperature to the size of hematite. So the controlling parameter is calcination temperature and the molar ratio of ethylene oxide to chloride ion and the concentration of ferric chloride. So the observation is same with the Shakil Akbar, that they found that the particle size increased with the increasing calcination temperature and the molar ratio of EO to iron chloride and the calcination temperature. In this study, the chloride ion act as agent that influence the morphology of the hematite. The chloride ion can change the hematite from the triangular plate to the disc-like shape. Okay, so last is the Chironga et al. They want to produce the hollow alpha hematite nanoparticle with size ranging around 100 nanoparticle. So the controlling parameter, yes, the molar ratio of ferric alkoxide to the 2-methoxyethanol and the calcination temperature. So they found that the formation of hollow hematite is start at ratio 1:9 compared to 1:3, and the particle size increase with the increasing calcination temperature. The reason behind this is the MOE influence the formation of spinazole. This spinazole is an intermediate of formation hollow hematite. This is because the ability of MOE to form a hydrogen bond between the ferric alkoxide chain polymer. The MOE cannot be replaced with other organic compound like octanol because they are unable to form hydrogen bond between the ferric alkoxide chain polymer. So we look at the co-precipitation method. Basically, it's the same with the sol gel method. However, co-precipitation method, the hematite, the nanoparticle will be precipitate in the solution. So we will dissolve the precursor and the precipitant. Then after stirring, the precipitation will occur. Then we filter the precipitate. Then we wash it using ethanol and water. Then we will calcine the precipitation at desired temperature. Then we got our desired hematite. So here I have a summarize. Okay, so let's see the paper by Jimmy Alexander Morales. He want to investigate the effect of different reaction time. Okay, so 24 hours and 48 hours. So the sample with 24 hours produce McHamite. However, the sample with 48 hours show a large amount of mixture of McHamite and hematites. It means that the longer the reaction time, the larger the amount of hematite that we can produce. So DLD Fuad, they want to observe the effect of precursor, which is the ferric sulfate, the precursor molarity to the size, morphology and crystallinity of hematite nanoparticle obtained. So the only controlling parameter is the molarity precursor. What they have found that the hematite obtained in a mixture of polygonal and hexagonal morphologies with the size range 90 to 44 nanometer, and the crystallinity is clearly found with increasing the precursor concentration. Lastly is Abdel Majid Louis. He want to study the effect of copper concentration on structure, optical and morphological of copper doped hematite. So the controlling parameter is the hematite with copper doping and without copper doping. So they found that the copper doped hematite produce the smaller size compared to the pure hematite, and the copper hematite nanoparticle is fine compared to pure hematite. So the decreasing in copper concentration will increase the size of nanoparticle. And the last is the smaller size and the best crystallinity of hematite produced with the highest copper doping. So we move to the hydrothermal method. Basically, it's the same with sol gel method. However, the solution, after stirring the solution, it will be transferred to the autoclave. So after heat at a desired temperature and desired reaction time, the nanoparticle will be cooled and will be washed with ethanol and water. Then it will be calcined at desired calcination temperature to produce nanoparticle. So this is the case study I have summarized in my table. Okay, so Patrick Constant et al. Want to investigate the effect of different surfactant. So they vary the types of surfactant, which is SDS, CTAB, Triton X100 and without surfactant. So they found that the smallest nanoparticle obtained using SDS surfactant and the largest hematite were prepared using the Triton X100, while the hematite obtained without the surfactant were not uniform in size. This is because the hematite without the surfactant will be sedimentation after a few minutes compared to the hematite with surfactant that remain well suspended. So the Mayon Zhu et al., they want to observe the morphology of hematite obtain and its electrochemical properties. So the controlling parameter is precursor concentration and the addition of surfactant. They found that the low concentration of precursor will produce the small size of hematite and the poor dispersion of hematite. So the addition surfactant result in good uniform and the best crystallinity. And lastly, the Munawar Khalil, they want to observe the effect of iron-iron, ammonium hydroxide concentration and the reaction time to hematite dispersity and size and its growth. So the good crystallinity with uniform size is obtained with the high concentration of ammonium hydroxide and the longest reaction time. And the formation of the hematite is start with the formation of geotite as an intermediate. This is because here there are no surfactant is used, so that the growth of hematite is follow oswald ripening mechanism. We consider it the growth of the surfactant is randomly. Okay, so we move to the instrument. Basically, in the hematite synthesizing, the instrument is X-ray diffraction. This instrument is used when the sample has a mixture of many phase of ferrum oxide, such as hematite and magnetite. And the second is scanning electron microscopy. This is a very common equipment because we want to see the morphology of the hematite obtained. And we move to the conclusion. Okay, what I have conclude here that all three methods are good in synthesizing nanoparticle. Each method has its own advantages and disadvantages to produce hematite nanoparticle. So the controlling specific parameter is very important in producing the desired nanoparticle. When we add the surfactant, so that the hematite obtained is uniform in size and has a best crystallinity, and at the high reaction temperature, we will produce the small particle size, and at high reaction temperature and with a high precursor concentration, we will produce a larger particle size. So that's all from me. Assalamualaikum warahmatullahi wabarakatuh.